Okay, last day we took a look at factoring x squared plus bx plus c, and now we're going to add in a value in front of the x squared. For instance, we're going to try and factor this. And just like we did last day, we should take a look and see if there's any kind of common factor between these terms, and there isn't. So now we're a little bit stuck. And today I'm going to give you a method to be able to factor these where we would otherwise get a little bit stuck. So, first step, identify the numbers a, b, and c. So once you have that, then I want you to multiply a times c. And in this case, 2 times negative 4 is negative 8. And then we need to find factors of this AC term, in this case negative 8, so just like we built last day, a little factor tree that add up to that middle term, 7. So last day we just had a 1 here, so 1 times c, we just used the number c. But now I need to do this, so negative 1 and positive 8. I think those multiply to negative 8 and add to 7. And now, if negative 1 and positive 8 is 7, then we rewrite the bx term. And so we're going to take this 7x term, we're going to rewrite it. So I keep this 2x squared, and I keep the minus 4, but rewrite this middle term as minus x plus 8x. So this part here is your 7x. It's just being rewritten. This step here is called decomposition, because we're decomposing 7 into 2 things. Okay, now we group the first 2 and group the last 2 and factor. And I'm going to call that step factor by grouping. So I take these first 2 and I look for common factors. So in this case, x. And what's left over is 2x take away 1. You can always check by redistributing. And now I'll go on to this next part. A common factor between these is 4, and I get 2x minus 1. And now you get a check. At this point, these 2 pieces have to be the same. So this is a nice thing with this method. Those 2 pieces will be the same. And since they're the same, then this and this, these 2 pieces of algebra are common pieces of algebra. And you'll see like this x plus 4 is left over. So what I essentially do is I factor out the 2x minus 1. So if I take 2x minus 1 out of this piece of algebra, and I take 2x minus 1 out of this piece of algebra, I get left over with the x plus 4 that I've double underlined. And I have factored 2x squared plus 7x minus 4 to 2x minus 1 and x plus 4. Let's take a look at another one. So 3x squared plus 8x plus 4, and again we're factoring this, and I'll leave the steps there. The last step after the check was to factor the 2 parts. So let's go through these. 3 times 4 is 12. 2 factors of 12 that add up to 8. That would be 6 and 2. So I decompose this to 6x and 2x, and the order of these does not matter. So if you switch the 2x and the 6x, it will also work. I group, so I look at the first 2 and I factor out a 3x, leaving over x plus 2. I look at the last 2, I factor out a 2, leaving over x plus 2. You check that these x plus 2's are the same, and they are, and the leftover part is 3x plus 2. So when I take x plus 2 out of here and x plus 2 out of here, I get the 3x plus 2 left over. We need to practice these so we can get up to a decent speed working with these questions. So I'll give you a couple more examples. Okay, 4x squared plus 10x minus 6. Make sure you factor out the common factor of 2 first. Always check for common factors first. And now I continue. So 2 times negative 3 is negative 6. 2 factors of negative 6 that add up to positive 5 are negative 1 and positive 6. Those multiply, those add. And so I can decompose. I get 2x squared minus an x plus 6x minus 3. I look at the first two terms, I factor out an x, leaving over 2x minus 1. So I'm just looking at this part inside these brackets. Maybe it'll be easier for you to see if I change the color of these brackets. So I'll just make these black brackets so you can see what I'm talking about. And I factor these two by taking out a 3, and that'll be 2x minus 1 left over. And 2x minus 1 and 2x minus 1 are common, so I take out a 2x minus 1, and I have x plus 3 left over. Note as well that this common factor stayed written on the front the entire time. Don't drop it, just leave it out front. It is one of the factors of this polynomial. Okay, another example. So again, I multiply the first and the last, I get negative 24. I'm going to add these up to 5, so negative 8, no, positive 8, and negative 3. And decompose, plus 8 minus 3x minus 2. And then common factor of 4x, left over 3x plus 2. A common factor with these ones is minus 1. So a negative goes in here and a negative goes in here. So you factor out the negative 1, and you're left over with positive 3x and positive 2. And this is the type that a lot of people have some trouble with when they see this minus sign here. Make sure you take the negative out of both terms. And so I get 3x plus 2 and 4x minus 1. Oh, and don't forget, you can write this as 4x minus 1 and 3x plus 2, because the order of factor multiplication doesn't make any difference. Okay, this is one of the kind of factoring I want to show you. Let's actually just try factoring this kind. X squared plus 8x plus 16. So this is from last day. I just have 1 times 16, and I add up to 8, and it's 4 and 4. So I get x plus 4 and another x plus 4. I don't want you to leave it like that. If you have two factors the same, we want to write them as that factor being squared. And this idea is actually called a perfect square factor. It comes in a special form. Either you have, and I'm using a's instead of x's, the variable really doesn't matter. Either you have something of this form, or if there's a negative in here, it'll be of this form. And what that means, if I compare these two to each other, what I'm looking at is I've got a perfect square on the beginning, and I've got 16 on the end. That's 4 squared, so perfect square on the end. And the middle term is the square root of this part. So that would be the square root of x squared is x, and the square root of 16 is 4. So I take the square roots to get a and b, and if it's 4 times x and then you double that, 8x, then this can automatically go to this form, which is x and then plus 4. So let me show you an example. We can determine whether or not we can use the shortcut. Let's see if we're allowed to with this question. Factor 40x squared minus 120x plus 90. Well, I'm kind of tricking you. Take out a 10 first. Now, this first term is a perfect square. It's 2x all squared. This last term is a perfect square. It's 3 squared. So if I take 2x and I take 3, and I double that, so 12x, do I get this middle term? Yes, I do. It's minus 12x. Perfect. That means that I can use the shortcut, because I have a perfect square, so I've got my common factor. I just leave that out front, and I can go straight to this answer, which is, this is my a, this is my b, 2x, 2x, and then minus 3, and I don't need to actually write it down twice because I know it's a perfect square, so just 2x minus 3 all squared. Okay, we'll get lots of practice with these ones in class. See you then.